The next one that we need to look at is next 7A. Okay, so go to the naming part. What is the name for the following compound? First thing you need to do, identify, is this ionic or covalent? We have phosphorus, we have nitrogen. So let's look on the periodic table, if I can find it. Alright, we have phosphorus, we have nitrogen. Both of these are nonmetals, right? So they're both nonmetals. This is a covalent compound, which means this 3 goes with the phosphorus and this 5 goes with the nitrogen. We can automatically cross out B. This 3 tells me that that would be a transition metal. This isn't the case, okay? It's not an ionic compound, okay? The rest of these all describe covalent compounds. Tri for phosphorus is correct, but this one doesn't have, it should be a penta, right, for the 5. This one is wrong. Penta for phosphorus is wrong because we know that there's 3 and that should be tri. So this answer is wrong. So your answer choice here has to be triphosphorus pentanitride. Alright, let's look at another naming example. Which one was it? 62. Okay. Alright, number 62. What is the name for the compound whose formula is SnCl2? Alright, first thing you need to do, ionic or covalent? Sn is a metal. It's a transition metal. Chlorine. We know that is a nonmetal. So this, right? So here's Sn. Where's 10? Here it is. Okay, so 10 is a metal. And y'all know this. And we have chlorine, which is a nonmetal. So this is an ionic compound. So with ionic compounds, remember, this number right here came from the cation. This came from 10, right? And there's a 1 right here, and that came from your chlorine. So this has to be, and now we can't say, because this is a transition metal, okay, it can't just be 10 chloride. We know that it can't be 10 dichloride because di is only used for covalent compounds, and this is ionic. So this is wrong. So now it's between these two. And again, you see this di right here, that automatically tells you that this answer choice is wrong as well. So your answer choice here should have been B. This 2 pertains to the 10 and it's a transition metal, ends in "ide." And what's next? Is there another one? 68. Okay. Number 68. Alright. Okay, in 1864, processes make ash, one-step process represented by the equation below. What is the name of the compound in the equation that contains both ionic bonds and covalent bonds? So, if it has an ionic it says it contains both ionic and covalent. So we can automatically cross out this one, right? This is all nonmetals. CO2, all nonmetals. NH3, all nonmetals. This is ionic, but do you see this is a metal and a nonmetal, right? But this says contains both ionic and covalent bonds. This would only be ionic bonds. We can cross out this one. So now we've got 2 compounds here. We have a metal and we have the polyatomic part, which is your, basically your covalent part of it. This is your ionic part. Here we've got a covalent part and we've got an ionic part. So anytime you have your polyatomic ions, those are covalent, right? But they're bound with sometimes, usually with something that's ionic if it's with the metal. So in this case, sodium chloride, we know this is sodium chloride. That's not right. Carbon dioxide is incorrect. Nitrogen trihydride. Nitrogen trihydride. So your answer choice here is aluminum chloride. Okay, is that it on those? And then we need the next part, which was B, right? Alright, 7B. Huh? Is it long? Well, I don't know what else to do. Well, it's two of them. I don't know. Alright, 7B. What is the correct formula for an aqueous strontium hydroxide? So, strontium hydroxide, we said OH was hydroxide, right? And strontium, you can look on your periodic table, is Sr. Where's strontium? Oh, it's group 2. Strontium is here, okay? So group 2 is going to have a 2 plus, OH is a 1 minus, and you can look for hydroxide on the back of your periodic table. Alright, so when we cross these, we're going to get, that goes there, so your answer choice should be here. This one is wrong, okay? This one is wrong because you forgot the 2. And this one, H2O, is just completely wrong because we're not talking about water in there. Alright, so that was B. What was the next one? Is that right? 7?
63,
63,
71.
71. Alright, so I need 63. Alright, 63. What is the correct formula for iron 3 phosphate? Alright, so iron 3, so that means that we're going to have Fe3+, right? Phosphate, it ends in 8, so we're going to look at the back of our polyatomic ion chart, and we're going to see that that is PO4 3-. Okay? And since this is a 3 and this is a 3, they're going to cancel out, right? And so what you end up with is this answer choice right here. This one is wrong because it's not a phosphate, it's just phosphorus. This one is wrong for the same reason. This is just phosphorus and not your phosphate, so that'd be phosphide. So the only other answer choices are these two, and because this is iron 3, they cancel out. 63, and what was the other one?
71.
I did 71.
You did that, okay.
There should be another
That's
one.
it.
B. No. Okay. And last one here. What is the correct formula for sulfur hexafluoride? So, sulfur, hexa tells me this is a what kind of compound? Tells me it's covalent, right? So we have sulfur and 6 fluorides, sulfur and 6 fluorides. This one is wrong because on covalent compounds we don't cross them. So this would be wrong for that reason. There's no di. This would require it to be di, and this one's just wrong. Okay. Now let's look at, you know what, I'm going to go ahead and do these. I'm going to go ahead and do those. It's in the same video. Okay. Alright, so now let's look at a couple of, so your electron dot formulas that we looked at, and we talked about these just a minute ago in the video. It says, depicts the bond between 2 fluorine atoms. So the first thing you have to ask yourself, 2 fluorine atoms, fluorine, if we look where they are on the periodic table, right? They're here. These are nonmetals, so a nonmetal and a nonmetal tells you it's a covalent compound. Remember, with covalent compounds, they're sharing electrons. They're not stealing electrons. So in this case, this one would be wrong because this electron is being transferred. Okay? Now, you know that fluorine has 7 electrons. So, and all of them want to have 8 total. So if we look at this first answer choice, it's got 2, 4, 6, 8, 2, 4, 6, 8, sharing 2. This one is wrong because fluorine has 7. You look where it is on the periodic table, right? It has 7 valence electrons. This example only shows it having 1, 2, 3, 4, 5, 6. This is wrong. Over here, this one shows it having 2, 4, 6, 8, 2, 4, 6, 8. Fluorine only has 7, so this answer choice is wrong. The right answer choice is A because it's got 1, 2, 3, 4, 5, 6, 7. This one has 1, 2, 3, 4, 5, 6, 7. And when they share, this one has a total of 8 and this one has a total of 8. They share 2 electrons. 57?
Yeah.
Alright. Alright, let's look at number 57. Okay. So on 57 it says, which of the following is the Lewis dot structure for CH4? And again, CH4, all nonmetals, carbon and hydrogen, both are nonmetals, so we're looking at something that's going to share electrons. If we look at carbon, we know that carbon has 1, 2, 3, 4 valence electrons. It's in, right, group 14, so it's got 4. Each hydrogen has 1, right? So it's going to share that 1 electron that it has with carbon, so that now it has 2, 2, 2, 2, and carbon has a total of 8. So the correct answer here on this one is going to be A. This one is definitely wrong. This one is wrong because, again, carbon only has 2, and carbon wants to have a total of 8. Hydrogen only wants to have 2. So this one is wrong. And same thing here. Hydrogen only wants to have 2. So this answer choice, D, is incorrect. What was the next one?
61.
61? All right, if we're looking at what is the electron dot formula describe the bonding found in magnesium bromide. Magnesium, metal, bromide, non-metal, okay? So in this case, we're talking about electrons being transferred. Automatically, you can look at this answer choice and know that it's wrong, and this answer choice and know that it's wrong. Because you're going to get positive and negative charges when you talk about ionic compounds, okay? Here they're sharing electrons. In these two examples, they're transferring them. Now, the key is this. If we look here, magnesium has 2 electrons to give away. Bromine has 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So if we look on our periodic table, bromine, which is in group 17, only has 7 valence electrons. Magnesium, which is in group 2, has 2 valence electrons. Magnesium has 2 here, bromine has 7. Problem over here is that we say 1, 2, 3, 4, 5, 6. So bromine needs to have 1 more valence electron. So this answer choice is wrong. Magnesium has 2 electrons to give away, and each bromine will accept 1. C is your correct answer. Which one was next?
66.
66. All right. All right, so which of the following is the correct electron dot structure for potassium chloride? Potassium is a metal. Chloride is a non-metal. We're talking about an ionic compound. Potassium is in group 1, so it has 1 valence electron. Chlorine is in group 17, so it has 7. This 1 electron is going to come over here, and so you end up with K plus and Cl minus. Right? This one is wrong because potassium is giving away an electron, so it's going to end up with a positive charge. Here, potassium only gave away 1 electron, so this answer choice is wrong. And the same thing here, your cation, which is your potassium, your metals will always be positive. So hear me say this again, metals will always be positive, so this one is wrong. So your correct answer choice there was A.
70.
Okay. All right, 70. Which of the following correctly shows how carbon and hydrogen bond to form a compound? Okay. Carbon and hydrogen are both nonmetals, so they're going to share their electrons. Automatically, these two answer choices are wrong because we see positive and negative charges. The next thing we know is that carbon has 4 valence electrons. It needs 4 more because remember, everybody's trying to get to 8. They want that octet rule, right? So you're going to need 4 hydrogens to bond with this 1 carbon. And so in order to form a compound, it would have to form like this, because in this case, carbon has not filled its octet. And 72, I believe.
You're getting 72? Yes.
All right, so number 72. Which electron dot formula represents a molecule having a non-polar covalent bond? Non-polar and covalent. The key here is that it's covalent, right? So automatically we can cross out which ones? We can cross out B because you have a metal and a non-metal, okay? Now, non-polar, okay, that means that there's the electrons aren't being shifted. So if you guys remember, when we look at our periodic table, these your nitrogen, oxygen, fluorine, chlorine, bromine, all of these elements over here are what we call electronegative. They want electrons more than the other atoms. Sulfur, it wants to have electrons. Chlorine wants to have electrons. So they're going to pull the electrons away from hydrogen towards it. So anytime you see these partial positives and partial negatives, these compounds are not nonpolar. These are what we call polar compounds. This is a polar compound. It's kind of like you have a positive and you have a negative. It's not a full positive or negative, okay? But it's like it's a pole. You know how you have magnets? The magnets have a positive and negative end. It's the same type of thing with this molecule. This is the negative end and this is the positive end, okay? So your answer choice here, you want the one that is nonpolar, so it has equal sharing, and here you have equal sharing. Both elements, both atoms are pulling the same on this compound here. Is that it?
And then you got 73, 65 and 73. But now it's like